Welcome back to our complex analysis class, and we continue with our question. In today's video, we want to look at harmonic function. Look at this question number 2. You have to show that this function that is given in two variables, that is x and y, which is equals to 3x squared y plus 2x squared minus y cubed minus 2x squared 2y squared is harmonic. For a function to be harmonic, it has to satisfy Laplace equation. In the previous video, we talked about analytic functions, and for a function to be analytic, it must satisfy Cauchy-Riemann equation. But for a function to be analytic, it must satisfy Laplace equation. So let's see whether this function is harmonic or not. So the question we have is uy, this function uxy. This is given as 3x squared y plus 2x squared plus 2x squared minus y cubed minus 2y squared minus 2y squared. Okay, and like I said, for a function to be harmonic, we are trying to verify if this function is harmonic. For a function to be harmonic, it must satisfy Laplace equation. And for a function to be analytic, it must satisfy Cauchy-Riemann equation. So we are not interested in Cauchy-Riemann in this video. We want to check whether this function satisfies the Laplace equation. What the Laplace equation says is that the second partial derivative in respect to x plus the u in respect to y must be equal to 0. If this condition is satisfied, then we can say that this function is harmonic. For the purpose of this video, I might not be using this is the u, and we can still represent this as u base 2x plus u base 2y, and this must be equal to 0. So both of them mean the same thing. It is just like you are going to Tangaza and some people decide, maybe you are coming from Gataka, you decide to go through Ngong before you reach Tangaza. You will still arrive, but the distance covered in physics will not be the same. So if you want to go through Hadi to Tangaza, that will be very easy for you. So I won't be writing all this, I will be using this notation. Okay, so let's see whether this function is harmonic or not. Now, the very first thing we need to do is to partially differentiate this in respect to x. The first one, we want to partially differentiate this in respect to x. If we do that, when you differentiate this, you bring what is here and multiply with what we have here. This is 3. Multiply by this, you will simply get 6. This is 6xy, because we are differentiating this in respect to x. And if we differentiate this in respect to x, we will get 4. This is plus 4x. We cannot differentiate negative y cubed because we are interested in differentiating this in respect to x. That is what we call partial differentiation. So now we want to do it again because this is second. We have to differentiate this 2 times. So we are going to take the second one. Now we are differentiating this in respect to x. If we differentiate this in respect to s, this x becomes 1. So what we have, and 1 times 6 is simply 6. So we are going to be left with 6y. And if you differentiate 4s, you will get 4. So this is what you have now. We also want to now differentiate this in respect to y. So let's see what we will get in respect to y the first time. In respect to y, you can see we've got y here. So we will have negative, that is not negative, sorry for that. Let's take a pen, good. So we will have 3 x squared, because you see here we've just we got y variable, and this y is simply 1. So we cannot do away with this since they are together. So we simply have 3x squared here. 3x squared minus 3y squared. Minus 3y squared. 3y squared. We cannot differentiate this one 2x squared because there is no y value. But we will differentiate this and we get minus 3y squared. And then we will get minus 4y. Minus 4y. Here in the final one, 2y squared will give us minus 4y. Now we want to do it again, to do it the second time. If we do it the second time, what you get here, it will be 6. We cannot differentiate this because we are differentiating in respect to y. So the whole of this becomes 0. But we are going to differentiate the second one. This becomes minus 6y, and this will become minus 4. Minus 6y minus 4. So now, this is as simple as it looks, but pay attention. We want to check if indeed it satisfies the Laplace equation. And what the Laplace equation says? The Laplace equation says that the second differentiation, when we differentiate this in respect to x 2 times, and we add the differentiation, the partial differentiation in respect to y 2 times, the answer must be equal to 0. So let's check what we have. The second, we've got in our second differentiation in respect to x, we've got 6y plus 4. And in the second differentiation in respect to y, this is in respect to x. In respect to y, we've got minus 6y. So this is minus 6y minus 4. Is this equal to 0? Let's see and find out. We've got 6y. This is plus 6y minus 6y. So this is 0. This is plus 4 minus 4. This also is gone. So the answer is indeed 0. Having done that, you can now conclude by saying that this function that we are given, x and y, is indeed harmonic function. It is indeed harmonic. And this is how you can prove that a function is harmonic or not. If you are given any question, simply pay attention when you are differentiating in respect to x. So you must have that basic knowledge of differentiation, partial differentiation. We call it partial differentiation because we are having 2 variables in one. And so you need to differentiate them differently, independently. So if we are differentiating in respect to x, you are only considering x values. But if you are differentiating in respect to y, then your attention should be on y values, even though they are mixed together. So you can see how easy it looks, but it can be confusing. So indeed, this function is harmonic because it satisfies the Laplace equation.